Hey YouTube, this is our first ever video, so it's going to be pretty goopy, but we've decided to just get started, because if you're going to fail, you may as well fail fast. We've made this channel as a video portfolio and a way of documenting projects that we're working on, and we tend to work on a couple at a time. Today we're going to introduce a Gantry robot that we've been working on, like this one. And it should be reasonably challenging but still achievable because it's planar and with only 2 joints. It means that we can start with this system and then mount that upside down on a sliding rail, giving it more versatility to move in 3-dimensional or Cartesian space.
The nice thing about doing a Gantry robot is that we can start with just the robot arm, just like this, which is a 2 degree of freedom, and then build the Gantry aspect at a later date, meaning we can make progress on it quite quickly. We are choosing to do this for a couple of reasons. One is to help reinforce our knowledge of kinematics, and as well as some coding, and also to start developing a bit of a portfolio as we are both finishing our robotics degrees and are hoping to find some fun work afterwards.
And we also just like working on projects, and building those into videos and a video portfolio helps to hold us accountable and means that we're definitely going to make some progress. And if we don't make some progress, then we're going to learn some lessons. So we see videos of loads of other people doing projects like this, and we wanted to get involved.
To start with, we looked for CAD files for a robot online. Whilst we would like to one day design and build our own, we don't currently have the skills to do that, and it'd be quite a big jump from just nothing, really. However, through these projects, we do aim to improve.
So after some searching for a basic robot arm online, we found some files on Thingiverse from a creator called Paco3. We liked the design, there was detailed descriptions, and with a hefty dose of foreshadowing, we thought it looked quite easy.
We downloaded and printed everything with the help of some friends at our Print Hub. If you want to get files printed and delivered, they've always been really helpful to us.
With all the parts printed, we laid them out and got ready for assembly, and this is where we hit our first big challenge. Whilst the description of the files on Thingiverse was really detailed, the links to all of the assembly instructions and bill of materials for a Ford, and subsequently we had to work from just 2 images to assemble the whole thing. Paco, if you're watching this, can you sort that one out?
Over the course of about 3 hours and 2 pots of coffee on a Tuesday afternoon, we managed to get it together and finally moving. We do have a detailed build procedure if you're looking to follow along, but for the sake of video progression, we haven't included it here. After that, it was onto the wiring. The servos we're using are a bit overkill, they are what we had access to.
If you want to buy servos, we'd recommend getting the recommended ones. I mean, that's sensible. And we will put a full bill of materials in the description below, or at least the things that we used, and where to source them from. So there's really no excuse not to try this project. If we can do it, basically anyone can.
The initial wiring was pretty basic, as after days of tinkering, we wanted to just get the thing moving. So we connected up the Arduino and wrote the most rudimentary script that we could think of.
And that was kind of where we got to in the first stage, which when we're recording it doesn't feel like a lot, but that's finding something, getting it printed, assembled and moving, and then sort of starting to think about how we're going to control it. And the first thing we realised was that we just didn't want to break it. And because we're using servos that are twice as powerful as recommended, we decided to find the physical limits of the robot. It's not designed in such a way that it stops itself from moving before it could break itself. So there are actually limits to where the servos can get to. So we basically had to find some hard stops and code them in.
We're going to leave this video here, but we will have an update on this project pretty soon, and are hoping to have the robot running with a manual controller. We have also toyed with the idea of building a digital twin for this robot, but that will come once the initial development is done.
If you've got any questions about the project, we'd be happy to answer them. Just ask them in the comments or message us. I mean, we don't really know how YouTube works yet. And we're pretty new here, so any advice or support is really appreciated, and looking forward to sharing some more projects with everyone soon. See you later.
Yeah, bye for now.